Thanks. I'm Dimitri Ognibene from University of Milan Bicocca. Today I present this work that has been done in collaboration with other groups in University of Essex and University of Munich. So we know that social interaction is a very important problem, and actually is very important when you try to interact with others to try to understand their point of view for various reasons. This kind of capability, social interaction, is due to the interaction itself of different processes. So we have sensory spatial motor skills, we have reasoning, inner speech, but we also have a dialogue, language, active perception, epistemic actions. So we have seen a lot of work about social interaction, intention recognition, and so on, that is based on visual, sensory, spatial motor skills. For example, models based on the mirror neurons, models based on teleological theory or other type of inverse planning. We have many models about that, based mostly on the perception of other behavior. But a crucial aspect of social interaction and understanding is language. We know that language changes over time. So we have kind of very proto-language, turn-taking, and similar early skills in children, in toddlers. And then adults develop much more advanced skills like understanding social contingencies, theory of mind, social conventions, and so on. Nowadays, we finally have some models that have some understanding of natural language, that can do some free form of dialogue, and there is a lot of interest in various places about their capability in a theory of mind. There is a lot of discussion about the capability of large language models and large multimodal models to understand theory of mind. But still, large language models have several limitations for considering embodiment and social interactions as we do. So they don't actually have something like turn-taking. They don't really have social contingency perception. They have limited pragmatic understanding, and also limited capability to make questions consistently and in a smart way. And initially, we had limited capabilities in terms of visomotor control, integration of other senses, no? But this is changing. Nowadays, there are many, many models that integrate large language models in the control of robots. So this step has been taken, and now we actually are exploring how to integrate perspective taking in this kind of models, in large language model. So last week we presented the thePerspAct, that was a model to create interaction that have common understanding, perspective taking, active perception, and question making. So in that work, we used the director task, a variation of it that requires to explore for information. So for those who don't know, the director task is a task where there is an agent that is asking the robot or the participant something, and he has a different perspective. He can see less things in the classical format of the participant. In our version, he could see less things on some part, but he also could have access to other part of the environment. So we consider three main factors, cognitive factors, that affect the performance of a participant in this type of task. One is common ground filtering, then there is imagining what the director sees and you don't see, and then also metacognitive factors as how much I actually want to overthink this situation. And we create a different set of environments where an agent and the director could interact, and we tested various versions of LLM, and saw that practically they are quite good in considering common ground filtering, but the other two factors still affect the system. So now we have this LLM. We tried to get some perspective taking and social interaction, but this conference is about social skill development and their modeling. And actually having language in social skill development is important. We can do many things. For example, another thing we just presented is what we call AI pedagogy, where we, instead of providing data directly to an AI, we have an agent teaching the other agent about that knowledge, and then we test the trained agent on various tasks. And we can change the style of teaching, the interaction type, and then we saw that actually with some combination of teaching style, the performance actually better than giving directly the data. But there are still many things to take into account if you want to do modeling on social skill development and using LLM. So, for example, when you create a model and you use a large language model, a large multimodal model, language is the core of the model. And when we are talking about development, there are many things that happen before the development of language, and many things that happen and may not be so related to language. And there are many mismatches at the level of architecture between an LLM and the development of a human brain. And in particular, a big issue is learning. They don't learn online. We learn online, or at most when we sleep, but mostly we learn online. And the other issue is that training is based mostly on adult language. There are no developmental phases inside these kind of systems. And it's computationally expensive to train them for developing, I don't know, if you have data on a specific phase, you want to train it on that phase, this will be very, very difficult. So what we try to see is if we can use what is called in-context learning, like prompting, that is very cheap, to reproduce different learning phases. And this results in two questions. If actually we can start the initial perception of our agent that should correspond to the kind of perception we expect in a child at that phase, and then if the resulting behavior with that kind of representation actually follows the learning phase, the development phase. So we developed this structure. We initially defined the experiment that we are working. We operationalize the phases, and then we create the initial conditions. We evaluate them, and so on. So actually, we used the same task that you saw before. We operationalized the Selman development phase. This is the first two. One is strongly egocentric. The other is differentiated. And we create evaluation criteria and phase-specific prompt that should be used to create the condition. And then we use these two components to create initial phase-specific description. It's like the first perception of the person when he's starting the task. So practically, for example, we obtain this egocentric view, starting from an objective view given the prompt, but also we have a differentiated where you can see that it's talking of itself of also the other agent. And then we have some evaluation criteria to check that the text actually follows the development phase. This is a sample of criteria. This is, for example, there is not much about other person in the thinking and description of the scene, while in the second phase, the other people start to appear in the description. And we can see that when we describe these two phases, practically phase one is correct, 0 is recognized correctly, the second one a bit less. And then we start a simulation, the behavior with this initial condition. And we also test different additional conditions for experiments. And actually, we can see different performance. Actually, these are errors. So in stage 0, the child is usually, the simulated child has more errors then so it doesn't complete the task perfectly, so actually is reproducing some aspect of what we want. But when we go and compare the actual annotations of the performance, we can see that while initial scene description is quite well produced by the agent, by the process, when we go and analyze the internal thinking of the agent while performing the action, it doesn't reflect most of the phase. So, for example, phase 0 reflects a lot about the director. And so doesn't seem to match with our request. So these are our conclusions. It is, at the moment, we are able to reproduce initial conditions, but during the interaction, there is a shift. So the idea is that, in this case, the interaction shift is due to the interaction between the language used for internal reasoning of the LLM and the dialogue with the director. So this creates some issues. So there are still a lot of things to do to integrate LLM and similar models in developmental research or modeling. Okay, and thank you. Sorry.
No, that's okay. So, do we have questions?
Okay.
Hi, again, thank you for the talk. It was quite interesting. A bit of a provocative question, maybe. Do we need to integrate LLMs in this kind of like perspective-taking models? Like if we see that, as you said, LLMs start and stop with language, while we don't, and that's probably why we have so good perspective-taking. Do you think we need to go all the way to make LLMs fiddle with them enough that they at some point arrive at that? Or do you think we can have like different routes that can then maybe merging with LLMs at some point, but starting with somewhere else to achieve that?
Well, I think you have many questions you want to try to answer integrating language. How to do that is difficult. This is our attempt. I think you want to answer those questions. LLM, the way we build them now is probably not the perfect way, and they are very different from the human brain. Do we have something better? That's the answer. I don't know. At the moment, we don't have better language systems than LLM, no?
Thanks.
Hi. Thank you for a very interesting talk. I was in the same vein. I am asking myself, how do the developmental stages make LLMs better, actually? Do you have an idea?
Okay, actually, I know, maybe it's cited in the slides, maybe it's lost on my history. There are a couple of works trying to characterize LLM developmental stage. There was one saying that LLM is like a 20 years old adult. You know, nowadays, 20 years old, you are a teenager, so it's later. So I don't know, actually. But there are, there is a lot about introducing new method of training them, no? So introducing developmental stages will mean changing the kind of data you provide over time. And I think there were a lot of talks about this, no? Modulating the input you provide. When these kind of experiments are crazy expensive, so I don't know.
So thank you. Let's thank our speaker.